Okay, I'm going to help you with understanding this program. So hopefully you've downloaded it and it's all running. And what you'll see at the very start are two arrays. Okay, and they're two-dimensional arrays. There's a little comma in there. They're like a grid. One's called current generation, and one called next generation. Obviously, every time we run a simulation, we want to work out the next generation based on what we know about the current generation, using those four simple rules of the animation. So if we go, let me try and show you these arrays as in a sort of visual fashion. Let's pretend there are two arrays like this. Now the arrays are actually, the only bit of the array we're interested in is 1 to 5. You'll notice though that I've got zeros around the edge. We've made the arrays one bigger either side than we want to, because we need to look around each cell. So if I was to choose a cell on the edge and I try to look around it, and I didn't have anything there, it might cause a few problems. We'd get a runtime error. So that's why we've used these sort of cells around the edge. But actually, we're only going to run the simulation on this area here. That's just me explain again. That's why when we set up the size of the array, we put the largest, we base it on the size of the console, we fill the entire console window, but we add 1, that's that bit around the edge. And we're also we're not using location 0, which is the bit at the beginning. Right, back to here. Let's see how the algorithm would work. So if you look at every time there's a 1 in this integer array, that means there's a cell living there, and if there's a 0, there isn't a cell living there. What your program has to do, it has to work its way through every single cell in the array, yeah, and decide whether in the next generation that cell there has a 0 or a 1. The important thing here is to do the check on this array, but the update on this array. So let me explain. Let's start at the beginning. Top left, 1, 1. So that's the cell we want to work out whether it's going to change. So we look at the equivalent location in the current generation, and we count the number of cells that are living around it. Now you can see, if I just highlight the area around it, there are 3 1s. So I've added up all the 1s around it and come to the number 3. Let's look over here on our rules. It's a living cell, you'll notice there's a 1 in there already. So it says any live cell with 2 or 3 live neighbours lives on to the next generation. So we know that cell is going to become a 1. Let's look at this guy. So then we move on to the next cell. And then we count the number of cells around this guy. And you'll notice this time there are 4 1s. It's important not to include the 1 that's actually the cell you're looking at. It's just around the cell. So there are 4. Unless we look at this rule, and that's rule number 3. Any live cell, because there's a 1 in it, with 3 or more live neighbours dies as if by overpopulation. So that guy gets set to 0. Let's look at this one. Now, this time it's a dead cell. But if we look around it, how many neighbours has it got? Well, it's got 4. Well, it stays as 0 because the only time a dead cell comes to life when there are 3 neighbours, and this one's got 4. Yeah, so that one stays still. But if we look at this next one, as we move along the row, we count the one around this one, you'll notice there are 3 neighbours. So that's a candidate for rule 4. And so we go to the equivalent cell in the next generation and put the 1 in there. And then we go through the array, row by row, column by column, until we work out what the next generation is. Now when we've worked out this next generation, it's really important then to copy that straight on top of that. We're done with the current generation. This is the new current generation. One more thing to remember when dealing with cells on arrays, that we always address the array row, then column. So if, for example, I wanted to access that in C#, what I would, that cell there in C#, that's cell 1 row 2 column, I would just scroll over here a second, I'd write the following command. I would say next generation, square brackets, 1, 2, like so. let's go back to the program. So whenever we talk about current generation, we talk about that array, and then the next generation, we talk about that array. What you need to do now is to fill in the code in this section here. I'll give you a few tips what to do. So follow those instructions. Put all the code for the simulation goes in here. Don't forget each time, of course, make sure you redraw the world, the new generation each time. Otherwise you won't see any changes. And I have suggested you put a bit of a system thread.sleep in it, otherwise it happens very, very quickly. Okay, so good luck with that.